Hi, I'm here to teach you about direct search method, which is used to find the roots of an equation, whether it's linear or non-linear. In this graph, we will see that the black line is represented by y is equal to fx. That is the function that is in this graph. Therefore, then we are given the range x of I to x of I plus 1, which is the interval where we will search the zero function of f of x. And then the delta x is the difference between these two intervals. So, for example, we are tasked to find the root of the equation 2e raised to negative x minus sine x from the intervals 6.25 to 6.30. So, from the starting iteration, we will see that x of I is equal to 6.25. And delta x is the difference between these two. So, 6.30 minus 6.25 is 0.05. And then, substituting these values, the x of I values, to find the f of x of I, we will find that f of x of I is equal to, it is equal to 0.0370. And then, substituting the value of x sub I plus 1 to the function, we will find that f of x sub I plus 1 is equal to negative 0.0131. And then we will find the product of these two functions to see if the root of the given function is within that interval. So the sign of these two when multiplied is equal to a negative sign, which means that the new x of I at the next interval will be equal to the x of I on the current interval, and the delta x of the new interval will be equal to the delta x divided by 2 of the current interval. So, here we go. So, 6.25 will be copied, and then the delta x will be half. And then, the new x of I plus 1 will be equal to the sum of these two, which is 6.275. And then, so finding the values of the f of the functions from the two x's, we will find that this remains the same, but the next one will change, which is equal to 0.0120. These two will generate a product of having a positive sign, which will mean that the new x of I will be equal to the current x of I. The new x of I will be equal to the x of I plus 1, and the delta x will remain as is. So, the next iteration, we will find that x of I will be equal to this 5. Delta x will remain as is. And then, the sum of these two will result in 6.300. There. Okay. So, we will do that again for the rest. Wait, 0.120. No, 0. Negative 0.0131. And then having the sign that is negative, we will do this again. This. So, the next. So, I will explain why we are basing what we will do from the x sub I and the x sub I plus 1 from these signs. It is because that if we graph this, if f of x sub I and f of x sub I plus 1 have the same signs, then it will not cross the x-axis. Therefore, we can conclude that the root is not present in that interval. Okay, so continuing from this, G6. since it is negative, we will copy the x of I as indicated here, 6.275, and having the half of delta x, which is 0.0125. And then the sum of these two will generate x of I plus 1, which is 6.2875. And then finding the equivalent f of x of these two, we will have 0.0120 negative 0.0006, which will again have a negative sign when multiplying. So, continuing on from that to the 10th iteration, we will find that the x of I at that point will be equal to 6.2859, and delta x will be equal to 0.0008. When taking the sum, it will generate 6.2867. Finding the equivalent of in the function 0.0010 and 0.0002 will generate a plus sign. So, since direct search method is a trial and error method, we are not after the exactest value of the root, but based from here, we can conclude that after 10 iterations, we can approximate that the root will be equal to the last value of x of I plus 1, which is 6.2867. So therefore, we can conclude that x will be equal to 6.2867, and it will generate an f of x that is near 0. So that's all. Thank you.